Well, hi there, boys and girls. We're going to do two short examples, some more solving equations using trig identities. And this first example is going to be a factoring example. I want you to think about if you had 2x squared minus 5x minus 3 equals 0, the way you would approach this is you would factor it and set both factors equal to 0. And this works out to be 2x plus 1 and then x minus 3. Let me make sure that's right. 2x squared minus 6x plus that. That's it. And so then you would set each factor equal to 0. We did something very similar to this, but we just haven't factored a trinomial yet. And you would get x equals negative 1/2 and then x equals 3. I'm going to do the same thing here, except my factored form is going to look like this. 2 sine x plus 1 times sine x minus 3. And you could multiply back through to see that 2 sine x times sine x, that's 2 sine squared. And then 2 sine x times negative 3 is negative 6 sine x, plus 1 times sine x. Those would come together to be minus 5 sine x, and then 1 times negative 3. So I have the factored form. And then you set each factor equal to 0. And we're going to figure these out. Alright, this first one would be subtract 1, divide by 2, you get sine x equals negative 1/2. And that happens in two places. Sine is negative in quadrant 3 and in quadrant 4. So you draw both of them. Sine is opposite over hypotenuse. That would be a square root of 3. Opposite over hypotenuse. And this reference angle here is a 30-degree reference angle. So my solution would be 210 plus 360n. That's for this rotation right here. And then my other solution would be all the way around here, which would be 330 plus 360n. That's if we're doing general solutions. Now, if it was just from 0 to 360, you would only say these two solutions right here. Now, the other equation is sine x minus 3 equals 0. You add 3 to both sides and you get sine x equals 3. And you try and figure out where sine is equal to 3 and draw opposite over hypotenuse. And that would not make sense because this is outside the domain of arc sine. You cannot arc sine 3 because that means that the opposite would be 3 times as big as the hypotenuse. This has no solution on this side. There is no solution for that. So my only answer would be here, whether it's general solutions or from 0 to 360. All right, let's do one more. And this one looks pretty crazy, but this happens to be the sine of a plus b form, where a would be 2x and b would be x. And so this simplifies into sine of 2x plus x equals 1. And so we have the sine of 3x equals 1. And then we've got to figure out where is sine equal to 1. Well, there's only one place where sine is equal to 1, and that happens at pi over 2. So the arc sine of 1 is equal to pi, that's a weird pi over 2, because the sine of 90 degrees is 1. So we're going to say 3x is equal to pi over 2 plus 2 pi n. Alright, so what we're going to do last is divide through by 3, and we'll get that x equals pi over 6 plus 2 pi over 3 n. And so what you can do, if you have to list all of the angles between 0 and 2 pi, you could start with pi over 6 and then add 2 pi over 3. I'm going to think about that with common denominators. That is 4 pi over 6. So the next one would be 5 pi over 6. And the next one would be 9 pi over 6. And then if you add 4 pi over 6 one more time, you get to 13 pi over 6. And that is already bigger than 2 pi. Because 2 pi would be 12 pi over 6. So if you just want the solutions from 0 to 2 pi, you just stop right there. If you wanted the general solution would be right here. Okay, so there's your examples for your video. I'm sorry, there's your video for tonight. And I will see you guys tomorrow. Tomorrow's our like Thanksgiving with our school family, so I'm excited about that. Deuces.